Today we're going to look at how to model using quadratic equations. So we have a problem here. A company that produces motorcycles has a production cost of C of x is equal to 2,000 minus 15x plus 0.05x squared. So it's important to keep in mind that the C of x is cost and the x is the number of motorcycles. Alright, it's going to help us understand and interpret the information that we're going to need here. So first I want to put this into standard form. C of x equals 0.05x squared minus 15x plus 2,000. So it will help me easily identify the a, the b, and the c. The a is 0.05, b is negative 15, c is 2,000. So keep in mind what this looks like. It looks like this, where the function here we're looking at is the cost. So the cost starts really high, it goes down, and then it hits a low point, and then the cost starts to go back up. So when we read A, how many motorcycles can be produced to minimize cost, we're looking for this point. This will have the lowest cost, and it will have the information for how many motorcycles result in the lowest cost. And to find that, we use x equals negative b over 2a. So in this case, we're looking at negative b is 15. 2a is 2 times 0.05, so that's 0.1, which reduces to 150. So this ordered pair has an x-coordinate of 150. And if we look, x is the number of motorcycles. So when it says how many motorcycles can be produced to minimize cost, the lowest cost is going to be where we have 150 motorcycles. Now if we want to know the actual minimum cost, we need to plug the number of motorcycles into the function. So c of x is 150, is equal to 0.05 x squared, so 150 squared, minus 15x, so 15 times 150, plus 2,000. Alright, so 150 squared, 22,500 times 0.05, so that's 1125, minus 15 times 150, so 2250, plus 2,000. So 1125 minus 2250 plus 2,000 is equal to 875. So remember what this is. This is a cost. So the minimum cost that they can produce, or that they can spend to produce, the minimum cost is $875. That is the y-coordinate of the vertex, 150, 875. Number 2, we have a revenue function here. Revenue for the number of bottles of vitamins sold is modeled by 500x minus 0.001x squared. So first I'm going to put this in standard form. R of x is equal to negative 0.001x squared plus 500x. Also, R of x is the revenue, which is money coming in, and the x is number of bottles sold. Now keep in mind this has an a value that is negative, so this is going to be an upside down parabola where the revenue steadily grows until it reaches the vertex, and then the revenue starts to go back down again. So once again I am looking for the vertex here, which will be my maximum revenue, and it will be an ordered pair. So I'll identify my A, B, and C. A is negative 0.001. B is 500. C is 0. We haven't really been using the C for this. So the number of bottles from my vertex is going to be the number sold to maximize the revenue. So the x-coordinate of the vertex is what I'm looking for here. Negative b over 2a. In this case, that's negative 500 over 2a, so 0.002. 0.001 times 2. Negative, because the a is negative, so. Alright, which means that our x-coordinate is going to be, let's see, 500 divided by 0.002. It's going to be 250,000. So in order to maximize revenue, they need to sell 250,000 bottles. So the x-coordinate is going to be 250,000. The actual maximum revenue I will have to find out by substituting this into the equation, or the function. So r of x, so r of 250,000 equals negative 0.001 x squared, so 250,000 squared. It's going to be a huge number, plus 500 times 250,000. Alright, so 250,000 squared is, yeah, a huge number, times negative 0.001, still pretty big, negative 625, and then there's 5 zeros. 1, 2, 3, 4, 5. So negative 62,500,000 plus, and then 500 times 250,000 is 125 with 1, 2, 3, 4, 5, 6 zeros. So 125 million. Alright, so minus 62, 5, 1, 2, 1, 2, 3. Alright, so it looks like, let me just double check that, 125, 1, 2, 3, 4, 5, 6, minus 625. It gives me 6, 2, 5, and then 5 zeros. 1, 2, 3, 4, 5. Alright, so my maximum revenue is $62,500,000. And I reach that by selling 250,000 bottles. I reach that revenue by selling 250,000 bottles. Any more than 250,000, my revenue starts to go down again. Any less than 250,000, my revenue, it goes down again. So that's my max revenue. It's the y-coordinate of the vertex. And that is the basics of modeling using quadratics.